Hello friends, welcome to Prismatis online class. In our today's class, we are going to look at what mathematical induction. In our previous class, we explained mathematical induction, the method of solving mathematical induction, and the application of mathematical induction. Even we go ahead and solve questions on what mathematical induction. But today we are going to look at the problem on the board that says, using mathematical induction, prove that P of n such that 1 times 2 plus 2 times 3 plus 3 times 4 plus plus n times n plus 1, close it, is it equal to n over 3 times n plus 1 times n plus 2? Okay, now let's go. Solution. Let's look at base step. The first case, which is what? Base step. And base step. Now let us test for P of 1. That is when n equals to 1. Now, if n is equal to 1, let's divide this. I'll test the right hand side, the left hand side, and as well as the left hand side. Now, when n equal to 1, let's have this. The first one, pick this one, the first one, which is what? 1.2. Is it equal to this, which is n into n plus 1? Close it. Now, when n equals to 1, we now have 1.n. 1.2 is equal to, you now replace this one into here. Did you get it right? Okay, which is now 1 into 1 plus 1. Close it. 1.2 is equal to 1 into what? 2. Close it. 1.2 is equal to 1.2. Proof is equal. Hence, you can now say hence P of 1 is true. Now let's check. This is for left hand side. Now let's check the right hand side of the equation. 1.2, is it equal to this? Now, which is n over 3 into n plus 1 into n plus 2. Close it. When n equals to 1, we have that 1.2 is equal to 1 over 3 into 1 plus 1 into 1 plus 2. Close it. 1.2, is it equal to 1 over 3 into what? 2 into what? 3. Close it. Now what do we have? 1.2, is it equal to 1 over 3 into what? 2 times 3. 2 times 3 is what? What? 6. Okay, 6. Now this 3 will cancel this. We have it as what? 1.2 is equal to 1.2. Proof. Hence, P of 1 is true. So if you go ahead and test this one, when n is equals to 2, check it, you still get it is true. When n is equals to 2, check n equals to 2, check it is true. When n equals to 3, check it is true. When n equals to 3, check it, it must be what? True. And that is how to do it. Okay, thanks. Now let's go to second case, case 2, which is what? Inductive step. Now in inductive step, we now say, let us test for P of k. That is when n equals to k. Now go to this question. We now have that P of k such that 1.2 plus 2.3 plus 3.4 plus anywhere you see n, call it k into k plus 1. Close it. Is it equal to k over 3 into k plus 1 into k plus 2? Hence, it is true. You conclude it is true. The assumption theory is true. So it is true for what? Whenever n is equals to k, it is what? True. Now, final case, that is step 3, which is now inductive hypothesis. Now let us test for what? P of what? K plus 1. That is n equal to k plus 1. That is n equals to k plus 1. Okay. That is n equals to k plus 1. Now let's go. If n equals to k plus 1, let's substitute here. 1 dot 2 plus 2 dot 3 plus 3 dot 4 plus dot plus what? K into k plus 1, close it, plus k plus 1 into k plus 1 plus 1, close it. Is it equal to? Now anywhere you see n, call it k plus 1. K plus 1 over 3 into what? K plus 1 plus 1, close it, into what? K plus 1 plus 2, close it. Now what do we have? We have that 1.2 plus 2.3 plus 3.4 plus k into k plus 1, close it, plus now k plus 1 bracket into bracket k. 1 plus 1 is what? 2. Close it. Is it equal to k plus 1 over 3 into bracket k? 1 plus 1 is what? 2. 2. Close it. Into k plus what? 1 plus 2 is what? 3. Close it. 3. Close it. Okay. What are we proving? We want to prove this, question in such a way that the left hand side, everything here after expansion must be equal to everything that is what? In the right hand side after expansion. So we want to prove in such a way that the expansion of left hand side must give you exactly the expansion of what? Right hand side. Okay. From equation 2, from this case 2, you can agree with me that from here to here is called what? Is called k over 3 into k plus 1, close it, into k plus what? 2. That is thing. We see everything here is equal to this, so we have to replace it. So now let us bring the left hand side of the equation. Let's bring out the left hand side of the equation. I hope you are done here. Let's bring out the left hand side of the equation. Okay. The left hand side of the equation from here is this, which is now for left hand side. So we have k over 3 into k plus 1 into k plus 2. Close it. Plus this one, which is what? K plus 1, close it, into what? K plus 2. Now let's expand. We have k over 3 in bracket. K times k will give us k square. K times 2 will give us a plus 2k. 1 times k, which is what? K plus k. 1 times 2, which is what? 2 plus 2. Close the bracket. Plus into big bracket. K times k, which is what? K square. K times 2, which is what? 2k. 1 times k, which is what, plus k. 1 times 2, which is what, 2. Close it. Now what are we going to do now? Let's collect like terms. Now let's collect like term. We have k over 3 into bracket k squared, 2k plus 2k plus k will give us what? 3k. The coefficient 2 plus 1, which will give us plus 3k, plus what? 2. Close it. Plus k square. 2k plus this will still give us what? 3k, plus 3k plus 2. Close it. Let's collect what? Like them. Okay. Before then, I have to break this one. K times k, we have this in as k power 3. K times this one, we have it as 3k square. K times 2, we have it as what? Plus 2k. All over what? 3. Plus k square plus 3k plus 2. All over what? 1. What do we do here? We find the LCM. LCM is 3 and 1 is what? 3. 3. 3 divided by 3 is what? 1. 1 times everything that's here. We have it as k power 3 plus 3k square plus 2k plus k divided by 1 is what? Okay, 3 divided by 1 is what? 3. 3 times everything that is here. That means 3 times k square will give us 3k square plus 3 times this one will give us what? 9k. 3 times this one will give us plus what? 6. Okay. Finally, we collect like terms. Looking at this one and this one are brothers. So we have it as k power 3 plus 3k. 3k will give us what? 6k square. 2k plus 9k will give us what? Plus 11k plus what? 6. All over what? 3. That is our expansion. That is our expansion. So call this in equation 1. Okay, equation 1. Now I hope you are through here. Okay, let's look at equation. Let's look at the right hand side. We have succeeded in getting our what? Left hand side of the equation. Look at the right hand side of the equation, which is now, we now say for right hand side. What do we have? We have k plus 1 over 3 into bracket what? 2 into bracket k. Into bracket k plus 2 into what? K plus 3. Close it. So what do? We need to expand the right hand side. So if we expand the right hand side and the answer we get after the expansion of the right hand side, if it is exactly equal to this answer, then means the p of k plus 1 is what? True. Let's go. Okay. K plus 1 over 3 into bracket k times k. K times k is what? K square. K times 3 will give us what? 3k. 2 times k will give us plus what? 2k. I hope you're understanding. Are you following? Okay. Now 2 times this will give us what? Plus 6. Close it. Now what do we have now? We have this as k plus 1 multiplied by, when you add up here, we have k square. This plus this will give us 5k plus what? Plus 6. Close it. All over what? This is all over 3. Let's multiply out. K times k will give us k power 3. K times 5 will give us what? 5k square. K times 6 will give us plus 6k. 1 to k square will give us plus 1k square. 1 to 5k will give us plus 5k. 1 to 6 will give us plus 6. It all over what? All over what? 3. Okay. Collection of like terms based on their powers. So collect based on their what? Powers. Okay. Now k power 3. This 5k to this one will give us what? 6k square. Are you with me? 6k plus 5k will give us what? 11k plus 11k plus what? 6 all over what? 3. Call it equation 2. Now you can realize, or you can agree with me, that hence equation 1 is equal to equation 2. Now, so far equation 1 is equal to equation 2, that is k power 3 plus 6k square plus 11k plus 6 all over 3 is equal to the same k power 3 plus 6k square plus 11k plus 6 all over what? Power what? All over what? 3. All over 3. You can see hence P of k plus 1 is true for all positive integer n. Therefore, our conclusion, P of 1, P of k and P of what? K plus 1 are true for all positive integer n. That is our conclusion, and that is how to do it. Thanks, and God bless you. Remember to subscribe to my YouTube channel, Prismatis Online Class, and follow me on Facebook, the same channel, Prismatis Online Class. Please like, share, and comment. Bye.